Alright, so the problem was to use the left and right endpoints and the given number of rectangles to find two approximations of the area of the region between the graph of the function and the x-axis over the given interval. Our x values are going from 2 to 4, and that's the given interval, and we have 4 rectangles. And what you did here is right. B minus A over n is 4 minus 2 over 4 equals 2 over 4, which is 1/2. And I just rewrote it right here. So what I have here is the summation formulas, which I'll show you how to use for this kind of problem in a second. But first we're going to do this, for this problem, it's the really easy way. Now I don't know if this is the way she wants you to do these, or the book wants you to do these, but if you're ever in a jam and you can't remember these summation formulas, and this is a good way to go ahead and solve this kind of problem. So we have x going from, on the interval 2 to 4, and this is the graph of our function. 2 to 4, and I'll write our function. F of x equals, not z, equals 2x squared minus x minus 1. I don't want to write it there either. F of x, 2x squared minus x minus 1. Alright, so that's our function, and that's the line, the graph of our function. What does delta x mean? Well, delta x means the width of every rectangle is 1/2. Well, we have 4 rectangles, and the width of every rectangle is 1/2. So that means our first rectangle goes from 2 to 2.5. Our second rectangle goes from 2.5 to 3. Our third rectangle goes from 3 to 3.5. And the fourth one goes from 3.5 to 4. Now it's a left endpoint approximation. The first one I'm going to do is a left endpoint approximation. So all of our rectangles will be under the curve, and our total approximation of the area under the curve is going to be less than the actual approximation. So if we're doing a left endpoint approximation, then we're going to start at our initial value, which is 2, and go up to the curve, and then that one's going to come, the width of that rectangle is 1/2, so it'll come straight down at 2.5. Now the next rectangle is going to start at f of 2.5, so it's going to start on the curve. It's going to go over 1/2, come down at 3. The next rectangle will start at f of 3, go out 1/2, down at 3.5, and the last rectangle will start at f of 3.5, go over 1/2, come down, messed it up at the end, come down at 4. So these are our 4 rectangles. And now looking at this, it's kind of a good idea to know what this means. What I'm doing here is I'm approximating the area under the curve with rectangles. So what I'm going to do is I'm going to add up each one of these rectangles, and the total of the area of each one of these rectangles will give me my approximation. And obviously it's going to be less than the actual area under the curve, because I'm missing this chunk right here, this chunk right here, and this chunk right here. So what is the area of each one of these rectangles? Well, the area was just base times height. Well, what's the base? Well, the base is 1/2, and our height is f of x. Our height is f of x. It's this function right here. Because when x equals 2, the function has this value. When x equals 2.5, the function has this value. F equals 3, the function has this value. F of 3.5, the function has this value. So it's our height, which is f of x, times 1/2. So in this case, it would be f of 2. This would be f of 2.5, f of 3, f of 3.5. So to figure out, just looking at the picture, to figure out what our total area would be, well, it would be the height, f of 2. So this is the first rectangle, the height of the first rectangle. That's the area of the first rectangle, plus f of 2.5 times 1/2, plus f of 3, scoot over a little bit, f of 3 times 1/2, plus f of 3.5 times 1/2. And that'll actually give us our left endpoint approximation. That will give us our left endpoint approximation. So the way I'm going to figure this out, because I don't like working with decimals and being squared and multiplied and subtracted, so I'm just going to plug this whole function here. I'm going to plug this function here into my y equals on the calculator. Now, I'm not advanced enough to where you can see this on the screen like Khan Academy yet, but just trust me when I say I'm doing it. So I'm going to y equals, and I have 2x squared minus x minus 1 in my y1 value. I'm going to go over to my table, second graph, and see what f of 2 is. I just hit 2 for my x value. F of 2 is 5. F of 2 is 5. So I get 5 times 1/2 plus, what's f of 2.5? So I plug that in on my table. F of 2.5 is 9 times 1/2. And if you didn't know how to plug this in on your calculator, you could just plug the value in. Just plug 2 in here, solve for it, and then multiply it by 1/2. Plug 2.5 in here, solve for it, multiply by 1/2. Alright, what's f of 3? That's 14, so we got 14 times 1/2 plus f of 3.5, 20 times 1/2. Alright, so we can start simplifying these terms. Well, 5 times 1/2 is 5 halves, plus 9 times 1/2, 9 halves, plus 14 times 1/2 is 7, plus 20 times 1/2 is 10, and this equals, let's try blue, 17 plus 14 halves, so 9 halves plus 5 halves is 14 halves, which is 7 plus 7 plus 10 is 14 plus 10 is 24. 24. And guess what? That is the left endpoint approximation. Where does that number go? It goes right here because it's less than the actual area. So 24. Our area is greater than 24 and less than some other number. And I'm going to do the other ones in another video.